Hello everyone, and this will be a set of 5 parts to the first segment of network attack and defense. So the main idea is just to review networking and also start to look at some of the vulnerabilities in networks. So as you know, the internet is just a series of tubes, and we are essentially concerned with the safety of the network and the internet in general, I guess. One of the classic studies of internet or network security was this sort of old book. It's more than 40 years old, or actually 30 years old, sorry. It's from 1986. It was written by someone named Cliff Stoll, who worked at the Lawrence Berkeley National Lab in California. It was a national research lab, and it all started with his boss asking him to resolve a 75-cent charge. Back in 1986, I guess it was worth some amount of money, maybe more than what it is worth now. So the book he wrote was The Cuckoo's Egg, and if you have heard about cuckoos, what cuckoos do, what the birds do is they lay their eggs, but they lay their eggs in other birds' nests, expecting these other birds to take care of the cuckoo's young. And this was like an analogy that Cliff Stoll came up with when as he saw a hacker break into the system and deposit programs that he could use to spy on different computers. So once he was asked by his boss to resolve this charge, he ended up tracing it to an unauthorized user. Turned out to be a hacker who gained root access by exploiting a vulnerability in the Emacs editor. It's still a popular editor. It's a nice, very nice editor, but it's usually used by people who want more sophisticated editors than something like Notepad. And the vulnerability this hacker used was the setuid vulnerability. And so this is one of those classic examples. The reason being that Cliff Stoll was pretty good at his job, and he was able to construct these jails, these Unix jails, this contained system within each Unix system where the person who was breaking into the system could not actually use the entire system but was contained. And this was like a good model for studying how to contain attacks, things like that, how to study attacks as they proceed in real time. So Cliff Stoll ended up tracking this one hacker for 10 months and tracked through phone lines. So this was back in when you had to dial in through phone lines, and Cliff tracked him all the way back through a satellite connection from Bremen in what was then West Germany, now it's Germany, and it turned out to be a KGB spy. So excellent reading, highly recommended, even though it is more than 30 years old. So back when networks were first set up, back in the 80s and 90s too, the goal was really just to get it working and make it so that people could communicate from one point on the network to another. Why? Because it was much better than the alternative, which was to send things like floppy disks or magnetic drives through the mail. Network communication was a lot faster. However, the thing was, people were just concerned about getting it working, and it was such a great thing to have that most people just thought, well, who's going to mess with this? This is such a great deal. And so there was minimal security way back then. Now that the internet is essentially a critical part of national infrastructure, just like roads and bridges and mail and package delivery, things like that, any kind of disruption in this critical infrastructure is going to be a big deal. So now we have real security goals, and some of the main goals are confidentiality, authenticity, and integrity of messages going on the internet. And remember, those three things are just binary, as either you have confidentiality or you don't, either you have authenticity and integrity or you don't. And then the fourth security goal would be availability. That is, you need to have your resources at each point in the network available for whoever is allowed to use these resources. One of the first problems that people ran into, it wasn't the first, but one of the first ones was spam. So if in case you haven't heard of spam, spam is, there's two things that spam could be. One is this product that was made originally only in Minnesota, but now it's made, I think, all over. And it's a big deal in Hawaii for some reason. But for whatever reason, I forget the history, but when people got junk email, almost right away it was called spam. I think you can click on this link to find out the exact history. The first spam email was sent in 1978. It was sent to about 400 people, and this was happening at a quote-unquote blazing speed of 56 kilobytes per second on the ARPANET, which was the precursor to the internet. It was sent by a salesman for the Digital Equipment Corporation, and all he was trying to do was really just sell more computers that the company produced. The DEC System 20 had just come out. Of course, the people who got this email, they weren't looking for it, and it was not liked by people who got the email, but it was actually good for sales of these computers, and it sort of worked. And also the vulnerability was just that mail was not designed to be secure. It still isn't, and by the way, you should know that. So email can be sent by anyone pretending to be anybody else. Most of the time we don't pretend to be someone else because we want replies to come back to us, things like that. So there was no real vulnerability except the protocol wasn't set up and still isn't set up in a secure way. So I have a bunch of spam that I can show you, and here's a couple things to note. The person who supposedly sent this email didn't have this actual email address, so this address doesn't match this person. Plus, the big giveaway was that Google flagged this with this big red sign saying, "Be careful with this message. It contains content that's typically used to steal personal information." And of course, it has a link in here, and that was it. It just says hi, and then this link, and a lot of things just didn't make sense. And then shortly after that, I got another email, supposedly from the same person, but with a new email address, and that's another giveaway. And then a warning from Gmail saying, why is this in spam? Because it's similar to messages that were detected by our spam filter. So most of the time these days, if you use email, chances are your email provider service will have a spam filter. And if they get through your spam filter, you probably want to flag emails like this as spam so that the spam filter can improve. Okay. Here's some more examples. Another person whose name doesn't match the email that it came from. Also, it's got a link and the big red warning from Gmail. Another person sent me an email and his name doesn't match the email address of the source, and a big red warning, and also another link. These were all links that probably contained malware. Here is another important message from Facebook. Scratch that. It was actually spam sent from Poland. How do you know that? Well, when you send this email, it looks like it's formatted just like emails that you would get from the actual Facebook. But then if you hover over some of these links, what you will see is an address like this. And this is the first thing that you should do if you get an email that doesn't look right. Hover over these links rather than clicking on them, And you will see in this case it was sent from Lodz in Poland. And so, as far as I know, official Facebook messages probably don't come from Poland, at least not to most people in the United States. Here's another kind of spam that a lot of students get: an urgent help desk message saying all kinds of things, that you have some problems with your email, please upgrade your server, and you have to click on this link. And then if you remember, you shouldn't click on these links, you should just hover over them and see if the clue as far as where this link is going to take you makes sense. So for example, this one came from accessdesk11.jigsy.com. Jigsy.com is just a place where you can set up free sites, and so chances are these sites are probably going to take you someplace you don't want to go. And so you get things like this webmail upgrade notification or ITS help desk, and they look like they come from your organization's help desk, but they're really probably not. It's very seldom that help desks will send you email like these. It's possible they might, but it's not very likely. So here's another one where if you hover over the link that says click here, you'll see actually it's coming from another jigsy.com website. So if you see things like that, things that you don't expect, chances are it's not a place where you want to go. So while the web may be the most visible part of the internet, there are a lot more components to network security, and we'll take a quick look at things like network protocols, network topologies, and connectivity, how to detect network intrusions, and how to use cryptographically secured protocols. So one thing that I'll just let you know that most of the examples that we will be using will be IPv4, just because it is simple to understand. It's all decimal digits for the numbers, and most people seem to prefer that over IPv6, which is probably the better protocol, but it's a little bit harder to read the addresses. Plus, there's a lot of features in IPv4 that are still quite commonly used. So remember, IPv4, if you haven't seen it before, you might want to maybe look it up. What is IPv4 as opposed to IPv6? IPv4 addresses consist of 4 octets. An octet is just a byte that is a set of 8 bits. And there's 4 of these bytes, giving you a total of 32 bits, 4 times 8. And 4 times 8, that's 32 bits, that's 4 bytes, and often we use the last byte to specify an address inside a subnet. So the first 3 bytes are considered to be like a subnet mask, and if these terms are not something that you've heard of before, you definitely want to look these up, and I could maybe, if required, I could set up a review sheet about subnetting and things like that. So for example, if you have an address like 192.168.1.0, typically, assuming we use just the last byte, that is this one, as the address inside the subnet, then it'll be the 0 over here will indicate that this is a network address. So, and when you use that network address, the built-in assumption is, assuming once again that the last byte is free to be used for addressing hosts, then anything other than 0 pretty much will be looking at various devices on the network. So it'll be 1 through 255. So once again, there is no networking interface with the address 192.168.1.0. Typically, although it's not required, a router in the subnet that sort of can take you outside this network will typically have the address 192.168.1.1. That is the first station that's possible to get an address in that network will typically be the router, and which will also be the gateway. Regular computers or LAN stations on that network will have addresses from 2 to 254, and you might ask what happened to 255. Well, the last one, that is the 255 address, is a broadcast address. That means that if you send to 255, all of the other machines from 1 through 254 will get that broadcast message. So that's usually how subnets are set up, and although this is not the only way, there's plenty of ways you can do subnetting. So if you have just the last byte, that is the last 8 bits out of the 32 used for host addresses, then the remaining 24 will be used for the network address. That's remaining 24 bits. And so a common way to denote these networks is using, rather than using subnetting or subnet masks, you can use subnet masks, but another way of doing this is to write this as 192.168.1.0/24. So this /24 is called CIDR notation, classless internet domain routing. And so what this once again means is that this is a network address, and these first 24 bits specify the network. The last 8 bits specify the LAN stations within that subnet, so 1 through 255. Okay.